Hi everyone, we are talking about how to evaluate limits analytically now. So now we can actually solve these by hand without necessarily having to use a calculator. Alright, so first we have some properties. Limits themselves are an operation and they have algebraic properties within themselves. So some things work with them and some things do not. So let's just talk about these briefly. The notation that we're going to use is our limit as x approaches c of f of x equals some L. Right? So what's important to note is that f of x here is our function. So f of x is our function. Hey, x approaches c, this is our x value. L is our y value. Okay. So c and L are our x and y values respectively in this case. Or over here in this notation, it would be c and m be our x and our y values respectively, right? But for our limit, so that doesn't necessarily mean that c or m exist in our function. Okay, but for our limit, they could both work. Alright, so first of all, our sum rule. So if we are adding two functions within a limit, then you just add the limits themselves. That's fine. Okay, same thing with the difference, same thing with product, same thing with quotient. Right, so it's really easy in that way. If you have a constant that you can kind of factor out, you can actually take this constant out of the limit entirely if you want, and then you just multiply that scalar by your limit. Okay, and if you have an exponent on the outside of everything. Okay, it has to be on the outside of everything. If this exponent here is on the inside, then that's you can't do this. Okay, but if you have an exponent on the outside of everything, it's just your limit to that exponent. Right, so you evaluate your limit first, then you evaluate your exponent. Okay, so first example here, we have f of x equals x minus 5 and g of x equals x squared. So those are my two functions I'm dealing with. They want me to evaluate a few things. So first, they just want me to do the limit as x approaches 1 of f of x. Easy enough. So I'm going to rewrite this as the limit as x approaches 1 of x minus 5. Okay, and when you receive a limit like this and you want to solve your limit, the first thing you should always do is just plug in your c value. Okay, whatever x is approaching, you should just plug that in for x, see what you get. Okay, if you get something bad, that just means either your limit doesn't exist or you need to try another method. But obviously it's the easiest method is just to plug in. So if I plug in 1, I get 1 minus 5, which is negative 4. I got a good number here, so that is fine. That's my limit. That's it. Right, same thing here. So I have the limit as x approaches 5 of g of x, which is x squared. I plug in 5. 5 squared is 25. Right, so I got a good number, totally fine. Right, totally fine. All right, now they want me to evaluate the limit as x approaches 1 of g of f of x. All right, so g of f of x, so I have a composition of functions. So I'm going to plug f into g. I get x minus 5 squared. Plug in 1, get 16. Totally fine. All right, let's move on. Very similar situation. So if I am given my function here, let's just plug in 2 first, see what happens. So if I plug in 2, I have 3 times 2 squared minus 5 times 2 plus 1. Right, so I have 4 times 3 is 12 minus 10 plus 1. So that's going to give me 3. And I got a good number, so I'm going to move on. Totally fine. I'm going to plug in 5. So I have my limit as x approaches 5 of cosine of, did not need to write all that actually. Okay, so I just have cosine of 5 pi over 6. So that's going to be negative root 3 over 2. Got a good number. I'm going to move on. Next, I have the limit as x approaches pi over 4 of tangent of 7x. So real quick, I'd like you to give this a shot, just like we've done with the last two examples. So pause the video, give this a shot, then unpause, see if you got what I got. Alright, so you should have gotten negative 1. Cool, let's move on. Okay, so sometimes we will have to use algebraic techniques to solve my limit. Sometimes you will not get something good if you plug in negative 3. And this is something that we've actually talked about in the past. It's called indeterminate form. So let's take a look at what happens with that. So in this case here, I have x squared plus x minus 6 over x plus 3. Now if I plug in negative 3, right, I'll have 9 minus 3 minus 6, so 0, over negative 3 plus 3, which is 0. And again, this is what we call indeterminate form. Extra letter there. Indeterminate form. Okay, and this doesn't mean that your function doesn't exist. This means that there's another way that we can solve this. Okay, that's all that means. So the first method that we're going to talk about is factoring. Okay, the first method we're going to talk about is factoring. So in this case, if I factor my numerator, I'll get x plus 3. If I was a good student, I would write my limit every step. Okay, I would get x plus 3 times x minus 2 over x plus 3. Right, I see that something does cancel here, so I'm going to go ahead and cancel that out. I have the limit as x approaches negative 3 of x minus 2. And now if I just plug in negative 3, I'll get negative 5. So I get a good number here, and that's totally fine. Okay. Now graphically, what this looks like is it's just the linear function x minus 2 where it doesn't exist at negative 3. So if I were to graph my function at negative 3, I would have a hole. However, I would still approach negative 5 from the left and from the right. Okay, so that's why my limit still would exist here, whereas the function does not. So this is an example of a function where the function doesn't exist at the point, but the limit does. So this is not a continuous function. Alright, for our last example, we have a difference of 2 cubes. What I would like you to do is, if you do not remember how to factor cubes, hey, I'd like you to look that up, give this a shot, and that is your homework for today. Alright, so go ahead and give this last example a shot. Hey, you do not have to graph. I don't care if you graph. Hey, but give this last example a shot. Hey, clearly if we plug in 3, we get 0 over 0. So try factoring this, see if you can get an answer, and you'll submit that via Classroom. Alright, that's it from me. Have a great rest of your day.